Back. So this is problem 6, section 3.1 from web work. Question is to find all the critical numbers for this given function. Fx equals x to the 1/3 minus x to the negative 2/3, and then list them separately. All right. So let's remind ourselves. C is a critical number if firstly derivative at C is 0 or derivative at C does not exist. Okay, these are the two possible scenarios for C to be a critical number. So either case we need to see whether we can find the derivative. All right, so derivative, so this looks like a power, it is a power. This looks like another power, it is a power. So f prime at x equals, let's get the 1/3 down, x to the power 1/3 minus 1. All right, that's the first piece. Minus, let's bring the negative 2/3 down, x to the power negative 2/3 minus 1. Okay, so notice, you know that 1 equals 3/3, right? So that's what we need to use here. So that tells me f prime equals 1/3 x to the power 1/3 minus 3/3 is negative 2/3, minus times minus plus 2/3 negative 2/3 x to the negative 2/3 minus 1, negative 2/3 minus 3/3, right? 1 is 3/3. So x power negative 5/3. All right. So let's write this down in a better fashion, right? So using fractions so we can see it better. Let me start with a fraction. 1 above, 3 below, and this is a negative exponent, so it goes below, x to the power 2/3. All right, that was the first piece. Next, plus another fraction, 2 above and 3 below, and this again goes to the denominator with a power of positive 5/3. Now this is looking better. Now let's simplify this somewhat. Notice 3 is common in the bottom. So let me get a fraction out, 1/3. Notice 2/3 is smaller than 5/3. So I can get the power x to the power 2/3 out. Okay, because that's a smaller power here. So that's a common factor. And now what's left? 1/3 x to the 2/3 is left. So 1 is there. Plus this gives me a 2 upstairs. And from 5/3 I took away 2/3. So notice from the power 5/3 I took away power 2/3. So what's left is power 3/3. So that's simply power 1. Okay, so let me remind you. So 3x to the power 2/3 is common in both. I got the 3 out from both sides. That's here. Then I took away x to the 2/3 power here. So nothing is left, only 1 is left. What about here? From 5/3 power, I took away 2/3 power. What's remainder is 3/3, which is power 1. So that's what is left. Now, when is f prime at, it's not C, it's x. So when is f prime not defined? Okay, It is not defined. Notice x equals 0 in the denominator 2 places. Okay, x equals 0 is a possible critical number. Okay, because that means f prime does not exist. The only catch is x equals 0 is not in our domain. See right here, x has negative power. So that tells me x cannot be 0. Alright. So it is not in my domain. Okay. So x equals 0 is not in our domain. So it doesn't count. So f prime not defined. The only option was x equals 0, which doesn't count. So the other option is f prime equals 0. So let's plug this in, right? So f prime x equals 0. Okay, so let's see how it goes. Take all of this expression equal 0. Okay, now I don't like fractions, so why don't I multiply both sides by 3x to the power 2/3, right? Because this is an equation, I can do that. I can multiply both sides by the same quantity. Notice what happens. If I multiply both sides by 3x to the power 2/3, and here I multiply 3x to the power 2/3, well, the right hand side gives me nothing, right? 0 times anything is 0. So the right hand side is 0. What happens to the left hand side? This cancels this. All I'm left with is this parenthesis. Okay, so I'll write the parenthesis over here. Okay, now when I write it in this fashion, you notice I don't need the parenthesis. Okay, all of this is here. So let me move the x to the other, let me move the 1 to the other side. I get, all I have left on the left hand side is 2 over x, and on the right hand side is -1. So I can think of -1 as a fraction, negative of 1 over 1. You see that? Now when I cross multiply, I get x times -1, or x times 1 is x, equals -1 times 2, so -2. So that's the only option I get for derivative equals 0. So let's plug in -2, submit, and we are fine. Okay, so long until next problem.